All right, so Elena is considering buying bracelets and necklaces as gifts for her friends. Bracelets cost $3 and necklaces cost $5. You spend no more than $30 on gifts. She needs at least 7 items. We're going to write a system. So first of all, bracelets are going to be X and Y is going to be necklaces, right? So how much are bracelets? $3. How much are bracelets? Or I'm sorry, yeah, necklaces. And then how much money can they spend in total? 30. Okay. What about at least 7 items? She's going to have X plus Y is greater than or equal to 7. Okay. So you wrote that system. Now with graphing, tomorrow you will be able to use your graphing calculator or your Desmos, but you can do this by hand. But if you did not do it by hand, this is what your graph should look like. So 3x plus 5y is greater than or equal to 30. And then x plus y is greater than or equal to 7. You can, once you type the inequality, if you hit equals, it puts the line underneath. If you want to just go into the little keyboard and do it that way, you can too. Okay, take a moment, graph this. Because I know half of y'all didn't even write it down. Graph it really quick. You should have shaded that green line below. You should shade the purple line above. Okay, so there should be this dark region right here. Okay. Now we're going to use the graph to find 2 possible combinations of bracelets and necklaces that they could buy. So I need a point that's inside here. Let's do 7, 1. That means that she would have had to have sold 7 bracelets and 1 necklace. What's another point that's inside this dark region?
8,
1 does work. So 8, 1. What'd you say, Aaliyah? How many? No, what'd you say? 12, 0? So that would be like right here. Look. Is that inside that dark region? 8, 0. 8, 0 works. 8, 0. Okay. What about set 7, 0? Yeah. Okay, that one works as well. Explain how the graph shows the combination of 2 bracelets and 5 necklaces. So if we look at the graph, it said 2 bracelets and 5 necklaces. So if we type in here 2, 5, does that point fall in between the shaded region? No. So it works for, so this is part D, it works for the item constraint, but not cost. Okay, so it says you need at least 3 pounds of fruit to make muffins. Blueberries cost $4 per pound. Strawberries cost $3 per pound. Okay, so looking at this, we have pounds of blueberries as our X. We've got pounds of strawberries for our Y. Now we're going to write an inequality. Let's look at the cost first. How much does it cost for blueberries? So we're going to say 4 times X. How much are strawberries? And how much money do we have in total?
21.
Now, that is only for the cost constraint. If I ask you to write a system, you need 2 inequalities. Okay? So looking at this, we said up to 3 pounds. I'm sorry, you need at least 3 pounds. So we're going to take the blueberries plus the strawberries, and we're going to say greater than 3. With systems of inequalities, you must have at least 2 inequalities. Now we're going to graph this one. Y'all don't stop saying words. She says temple. Bro, it don't matter.
It does. How about nobody's talking to you?
Gosh.
Guys, I'm gonna go by 10 minutes.
Okay, so looking at this, you can identify two combinations of pounds of blueberries and strawberries that you can purchase to make muffins. So looking at this, we need, guys, okay, we need where this dark shaded region is. That's going to be our possible solution. So what's one point that's in this whole region? 2, 2. Yep. So 2, 2 would be 1. 0, 4 would be 1. Or 1 would be 1. And what was it? 4, 0? 4, 0 would be 1. Would 4, 2 be 1? You mean 2, 4? There you go. Okay. That makes sense? You need where they overlap. Okay. A lot of y'all put not where they overlap. Now, determine if you can purchase 4 pounds of blueberries and 1 pound of strawberries. So if I come in here and I say 4 pounds of blueberries and 1 pound of strawberries, does that point lie inside of this region? Yes. So could that work? Yes. So coming in here, yes, it would work because it falls in shaded region. Fantastic. All right. So Devin saved $24 to spend at the fair, but doesn't want to spend all the money. Okay. Recall that the games cost $2 each and the rides cost $3 each. If you want to go ahead and write the inequality first, it makes it a little bit easier. So X represents the number of games and Y represents the number of rides. So we can do 2 times each game plus 3 times each ride. And we don't want to spend more than $24. So we spend less than $24. Now it's not going to be equal to because they don't want to spend all their money, right? Now, if you graph this, what are possible combinations that you could have? 3, 2. 2, 2. Okay, does that make sense? Anything that would be in that shaded region would work for this. Okay, go ahead on the next slide. Go ahead and graph these two inequalities. Use Desmos to check, but go ahead and try it on your own. All right, on this one, this is already in y equals mx plus b. So we're going to graph our y-intercept. And then we're going to go down 3 to the right 1. Down 3 to the right 1. Down 3 to the right 1. And then it's going to be a dashed line. Now, are we going to shade above or below? Well, y is greater than, we're going to shade above. Okay. Y is greater than, so we're going to shade above. Now, on the next one, we have to make sure that, okay, so now we're going to rewrite this in y equals mx plus b. We're going to move that 2x to the other side. We're going to have negative 5y is greater than or equal to negative 2x plus 10. We're going to divide everything by negative 5. When we divide by a negative, we're going to switch the sign, and that's going to give me 2/5 x minus 2. Okay. Then I'm going to plot negative 2, and then I'm going to go up 2 over 5, up 2 over 5. We'll repeat that process on the other side. Down 2 over 5. down to over 5. Then we're going to draw a straight line. Is this going to be above or below? Pause. No. Below. Y is less than or equal to. If you can't plot regular points, if I gave you a line and you can't plot that, we've got to do some work. Because you got to know how to do that, because that quadratics unit is all graphing. And if you don't understand how to read a graph, draw a graph, etc., that's going to be miserable for you. Okay? Take a moment, look at the next slide. Go ahead and work on that. Okay. So we're going to rewrite this in y equals mx plus b form. So we're going to add 6x to both sides. And then we're going to divide by -3. When we do that, it'll switch the sign. So this will give me -2x minus 4. When you graph this, it should look something like this. And then it's going to be a dashed line. And is it going to shade above or below? Above. Okay. Again, you could have plugged this into Desmos, but if you needed to do it by hand, you could. So on this first one, we have 0, 6. So 0, 6. This point right here, is that inside of that blue shaded region? That's a solution. Fantastic. Now this next one's a little tricky. It has x equals 2. So that's this line right here. And then it has y equals 3. Okay. So in the entire time on this line, is that a solution? The entire time. Okay, so we're going to say not enough information because they didn't tell us where it stopped, right? Okay. On this next one, we got x equals 9. Not enough information because they didn't tell us when it stopped, right? It's partially a solution, but some of it may not be. What about this last one? -1, 2. Not a solution. Why not? Because it's on the dashed line and not a solid line. Okay, so dashed. And they didn't tell us the cutoff. Same thing on this one. And outside of the shaded region. Okay. Questions on that? Okay. Tomorrow, your unit test is here. Okay. So with that being said, your review guide, the Unit 2 review guide, you are going to turn that in tomorrow. Okay. So yesterday we went over problems 1 and 6. So right now, you've got about 26 minutes to work through problems 2, 3, 4, 5, and 7. Okay. Yes. So you need to work on it now. When you walk in tomorrow, you're handing it in. Okay.